Hi students, welcome to today's class. In the today's class, I am going to explain in the definite integration, so the results on inequalities. Okay now, the first result is if f of x is greater than or equal to 0 in the closed interval a comma b, then the integral a to b f of x dx is greater than or equal to 0. So, whenever this type of, in this class I will explain majority of the, almost I will cover in all inequality results. But whenever this type of results came, the best thing is draw the diagram for each and every result. So, if you remember the results in diagrammatically, you will remember it forever. Don't by heart the result. Here what he is saying, f of x is a function, its domain is a comma b, closed a comma b, that means including a and b. F of x is greater than or equal to 0, understand, for all x in a comma b. What is the meaning of this? Let us try to draw the diagram, right. So, I am going to draw the diagram. So, here see here x axis, y axis, origin. Okay now. First of all, your x belongs to a comma b, that is closed bracket. So, this and a. So, this is a and it is a and it is b. F of x greater than or equal to 0 means what? F of x means y value. Y value is positive y axis. So, this is your y is equal to f of x. That means it lies above the x axis. Okay, na? Otherwise, it may coincides with the x axis. Y is equal to 0 or coincides with x axis or lies above the x axis. Then, so your function is like this curve. Function is nothing but curve. Then what is saying? Integral a to b f of x dx. What is the meaning of this? What is the meaning of this? It is the area bounded between the curve f of x and the lines x is equal to a, x is equal to b and x axis. That means, so if you draw this like this, definitely, so this what you will get here, this is the area. Surely this area is, that is f of x dx is greater than or equal to 0 or not? Definitely it will be easy, greater than or equal to 0, it never be negative. Okay, na? Maybe 0. When it is 0, if it is the curve is coincides with the x axis. If the curve is coincides with the x axis, then the area is equal to 0. Understand this? So, this is the first property of inequalities. Okay. So, the same thing will be extended for second problem also. Here there are two curves are there, f of x and g of x. There are two curves are there. For them also the domain is a to b. The domain is a to b. Both the functions are defined a to b such that f of x is less than or equal to g of x. Let us draw the graph. Now coming to this, here y axis and it is x axis and y axis. Now your domain is closed bracket a and b. This is a and it is b. Okay. Here there are two functions are there. What are they? F of x is less than or equal to g of x. That means, so if it is g of x and it is f of x. So your f of x always less than or equal to g of x. That means sometimes it may be both may be coincides. See here f of x y value, g of x y value. So y value is f of x is less than or equal to g of x. Then what he is saying? What he is saying? So the area bounded between the curve. So see here, area bounded by the curve f of x is this. F of x is this. The area bounded by the curve g of x is equal to this. G of x curve area bounded is this. This is the area bounded by g of x with respect to a and b, x is equal to a and x b. Clearly, it is seeing that area f a to b f of x dx is less than or equal to a to b g of x dx. Understand? So, this is the g of x area is a bigger one, and the area under the curve f of x is smaller one. Okay, na? So, this is a very nice inequality. Then we can extend this theorem to n number of functions. So, if it is f of 1 is less than, f of 2 is less than, so on, f of n, there are n number of functions are there which are defined in the interval a and b. Okay, let us see the diagrammatically. See these functions diagrammatically. Let us see what happens. So, this is a y-axis and it is x-axis and y-axis. There are n number of functions which are defined between a and b. So, here f of 1 is less than or equal to f of 2x. So, this is equal to f of 1x and it is f of 2x and it is f of 3x, so on last f of n x, f of nx. Okay, now, right. So, if you observe now what is the meaning of this a to b f of f1 of x dx means what? The area under the curve f of x. So, this is the area, this area. Integral a to b f2 of x dx means what? So, this is the area, this area. So, if you observe here, so these areas. So, we can, anybody can say that the area under the curve f1 of x is less than area under the curve f2 of x, and it is less than area under the curve f3 of x, and so on like this. So, these are the first two inequalities. Okay, na? So, let us see some more inequalities. Dear students, let us see a small problem. So, what are we learned basing on the what we learned? So, here one inequality is there, we have to prove it. So, 0 less than integral 0 to 1 x power 7 cubed root of this is a dx x power 7 and upon cubed root of 1 plus x power 8 less than 1 by 7. That inequality we have to prove. Generally, students what they thought it, no, they will concentrate on this. They will concentrate on this, they will start doing that. Put, so here x power 8 is there, no. So, put x power 8 is equal to some t, x power 8 is equal to some t. So, that means they will start like this, they will start like doing. So, put x power 8 is equal to some t. So, this is equal to 8 into x power 7 dx is equal to dt. And they try to find out this inequality. They try to find out the value of this integral, so that, and they will prove that it is less than, the value is less between 0 to 1 by 8. They try to solve it, but no need to do all those things here. The best thing is using inequalities we can prove easily. Let us see that. Can I say that we know what we know? 0 less than x power 7 upon cubed root of 1 plus x power 8 less than x power 7. Can I prove that for all x belongs to 0 to 1? Can I write? Can this inequality be right? Yes, it is right. You can take any number. So, here this x power 7 by cubed root of 1 plus x power 8 is always greater than 0. Why? Because here x belongs to 0 to 1. There won't be any negative value. Okay, now, right. So, here x power 7, something you are dividing in the base, you are dividing with the denominator, some quantity, positive quantity. So, definitely x power 7 is x power 7 by cubed root of 1 plus x power 8 is less than x power 7. So, if you want to try it, take any one value from 0 to 1, take 1 by 2, substitute here, you will get the result. Okay, now, so if you get the idea, the problem is over. Now, this is f of x, this is g of x, this is h of x. So, f of x is less than, g of x is less than, x of x means what? Their integral values are also less than. So, then what I will do? So, this is I will do 0 less than, 0 to 1 less than, integral 0 to 1 x power 7 cubed root of 1 plus x power 8 dx less than integral 0 to 1 x power 7 dx. Understand this? So, 0 to 1 0. So, this is 0 less than, see this is, don't try to find out, put it as it is, cube root of 1 plus x power 8 dx less than x power 7 integral x power 8 by 8. Upper limit, lower limit, this is nothing but 1 by 8. So therefore, we got the result or not? 0 less than 1 by 8. We proved this. Okay. So instead of taking this, yes, you can do using this substitution also you can do, but it takes so much time. So instead of doing that in this method, if you know that this result x power 7 less than x power 7, the problem will be very easily we can solve it. Okay now. So let us see some more properties. Welcome to this point. So this is also one of the very important topic point. This will be useful for solving the problem. So what is this problem? Let us see this. If absolute maximum and absolute minimum value of f of x when x belongs to a and b closed bracket, that means your domain of the function is from a to b. Okay. So our concentration should be on between a and b only. Is m and small a, capital M and small. So absolute maximum is capital M, absolute minimum is small m respectively. Then, so absolute minimum into b minus a is less than or equal to integral a to b f of x dx is less than or equal to absolute maximum into b minus a. Whenever such a type of one inequalities or anything is given, so immediately draw the diagram for that. Okay. So if you draw the diagram, by seeing the diagram only you can remember the results. Okay. So let us try to draw the diagram. Okay. So here, so this is x axis and y axis. Our function is, our discussion is between a and b only. So therefore this is x is equal to a and it is x is equal to b. Understand? Including a and b. Now he is saying there is a function, the function has maximum and minimum. It has maximum and minimum in the interval a to b. In the interval a to b. Now then what will be your graph? Definitely, so if you take this as a bound, x is equal to a and x is equal to b. If you take this bound as, then it has both maximum and minimum in the interval a and b. That means what? So it is a maximum and a minimum value it have. So this is capital M and it is small m. So this is absolute maximum and absolute minimum he is saying. Now what he is saying is, area bounded between the curve. So what is the meaning of this? Small m into b minus a. What is the meaning of this? B minus a means what? B minus a. This is the length. This length. B minus a means this length. Up to here b. See here it is a. B minus a means this length. M means how much? So this is m length. So this is absolute means this is m. This is m. This length is m. That means m into b minus a. M is length, this is breadth. There will be a rectangle, no? There will be a rectangle. Okay. So this is a rectangle, area of the rectangle in which the length is b minus a, length is b minus a, height is, sorry, breadth is m. This is the area, this rectangle area. Understand this? So this is the length into breadth. Otherwise, this is, we call it as a length and a breadth. Length means b minus a, breadth means m. So this is the area of the rectangle. Let us see that capital M into b minus a. What is b minus a? This is length. M means what? Up to here m. Okay, I will draw like this. This is m. This is m. Understand? Total area. Total area. That means I will use this red color. If it is, I will use red color. I will use black color. Something. Okay, this area. Complete area. This area. Complete area. This rectangle area. So otherwise we can give the names A, B, C, D, E, F. Understand? ABCD is a small rectangle, ABEF is a big rectangle. Understand this? Okay, forget about this thing, forget about this. Just by seeing the area of the rectangle ABCD is less than the area of the rectangle ABEF, right or wrong? This inequality, first and last. Obviously, if we observe, what is this value? This is the area bounded between the curve y is equal to f of x, y is equal to f of x, then I will draw with some red color. So, red color, this is. So, if you observe, see here, area, small rectangle area, blue color, this is a blue color, less than or equal to a to b f of x dx, red color, this is a red color, less than or equal to capital M b minus a, that is a black color. I will use it in a black color. Is it right or wrong? You tell me. Yes, it is right, obviously. So, the area of the rectangle ABCD is less than the area under the curve y is equal to f of x bounded between a to b f of x, and it is less than or equal to the big rectangle ABCD. So, when it is only strictly less than, when it is equality will be, satisfied. The equality will be satisfied when this curve coincides with the x-axis. When the curve coincides with x-axis. When the curve coincides with x-axis, then what happens? There won't be maxima and minima. There won't be any maxima and minima. This will get 0, you will get 0, this you will get 0. Understand? So, like that, so whatever may be the inequality we got, if you draw the diagram, if you remember this diagrammatically, so guarantee you will understand this forever. Okay, now? So, this is a rectangle, it is also a rectangle, small rectangle, big rectangle, and this is a curve under big rectangle and small rectangle. Okay, I hope that you understand this point. Let us see some more points. We have the property. So, just to remember that property. So, remember the diagram, small rectangle, big rectangle diagram. So, what is the area of the small rectangle? So, small m into b minus a less than or equal to area of the figure, that is a to b f of x dx is less than or equal to area of the big rectangle, that is capital M into b minus a. Understand? So, everything is clear. Small m is equal to how much? 1 by 2. 1 by 2 into. This is a and it is b. So, this is equal to 2 minus 0. Less than or equal to 0 to 2 f of x dx is less than or equal to capital M. Capital M is equal to how much we got? 3 by 5. So, this is equal to 2 minus 0. Understand? So, got the answer. So, this is equal to 2 will get cancelled, 1 less than or equal to 0 to 2, that function f minus x upon 9 minus x square dx less than or equal to 3 2s are 6 by 5. So, we proved this result. Okay. So, very nice problem this is. So, first I have taken f of x. So, in the interval 0 to 2, I have find out the absolute maxima and absolute minima. To find out that, we have to find out f dash of x. So, for maxima and minima, okay. So, absolute maxima, no need to find out f double dash of x, no need to find out f double dash of x. So, we got x is equal to 1 and x is equal to 9. We discarded x is equal to 9. Why? Because that 9 does not belongs to our interval 0 to 2. Therefore, your absolute maxima lies at either 0 or 1 or 2. So, we find out that maxima and minima value, and we apply this property. So, using this property only you can solve this problem. Okay, now welcome to this property. So, very nice property. Integral a to b f of x dx is less than or equal to integral a to b modulus of f of x dx. So, first to understand this property, first of all you should know the graph of f of x and the modulus of f of x. F of x graph and modulus of f of x graph. If you know that, the understanding this concept is very easy. So, whatever may be that, for example, there is a graph is there. For example, your graph is, so this is x-axis and it is x-axis and y-axis. Okay, so if it is your graph is like this, so this is y is equal to f of x graph. That is your y is equal to f of x graph. Like this it is there. Y is equal to f of x graph. Now what is y is equal to modulus of f of x graph? Y is equal to modulus of f of x graph means whatever may be in the down. So this is x-axis, what is under whatever may be this below the x-axis, whatever may be in the below the x-axis, you have to take the reflection of that with respect to x-axis. That means this will be like this and this point. So whatever may be that, it will come again, it is there like this. So this is y is equal to a modulus of f of x. Y is equal to modulus. That means what? Y takes only positive values. Y is not, y means these values are not taking negative values. So it should take positive values. That's why you have to take the reflection of that graph with respect to x-axis. So if you know that point, that means f of x modulus f of x. If you know that property, the graph nature, then understanding this property is very, very easy one. Now try to understand this graph property. So what he is saying means that is here x-axis and it is y-axis and it is a and it is b. So there is an area bounded by the curve y is equal to f of x between the points a and b. Okay, a and b. A and b. So this is equal to a, this is b. Okay, now let us check that. Let us see that y is equal to f of x. So this is like this is there. Okay, now. So this is the area bounded by the curve. So this is the curve. This is the area bounded by. So y is equal to f of x. Okay, now this is y is equal to f of x curve bounded between a and b. This is the area. So he is saying this area is less than or equal to the area. This area is less than or equal to. He is saying that this area is less than or equal to, same thing, x-axis, y-axis. So this is x is equal to a and it is x is equal to b. X is equal to a and x is equal to b. So what is so this is a f of x and it will be, this is the part, this area. This area. Understand this? So this is y is equal to modulus of f of x. So this is y is equal to f of x graph. This is y is equal to modulus of f of x graph. So the area bounded by the curve y is equal to f of x with x is equal to a, x is equal to b is something less than or equal to the area bounded between the curve a to b f of x dx. So here you are saying that why? Because you are saying here a to b f of x dx, sometimes now it is not actually area, the value. So if you put a modulus here, then you will get the area of the region. That means you may, there is a chance of getting negative values here. There is a chance of getting negative values, but here there is always getting positive value. Why? Because here modulus of x is there, no? Definitely you will get positive values only. Okay. So this is a to b f of x area. So this is something negative you will get, here you will get positive. Something there is a chance of getting negative values. Okay, right. So this is also something positive you will get. So negative is always less than or equal to positive. Okay, I hope that you understand this solution. Let us go for next point. Dear students, welcome to one more property. So this is, there are two functions are here. There is f of x into g of x, f of x into product of two functions, f of x into g of x. This is a modulus is there here. So integral a to b f of x into g of x, it is less than or equal to under square root of a to b f square of x dx into a to b g square of x dx. Okay, now right. Then how to remember this formula? How to remember this formula? Okay, now. So diagrammatically this is something difficult to express. Why? Because we don't know f of x into g of x, how the graph will be. Okay, that depends upon the f of x graph and g of x graph. Okay, then how to remember? So there is very easy result is there. So what is the formula of root of x square is equal to mod x? This is the result we have. Root of x square is equal to mod x. See here, this is square is there, this is also square is there. So remember that this is something whole square. So root of whole square, this is equal to mod x. Understand how to remember? This is one way of remembering. I am telling how to remember this. So this a to b dx is separates for both a to b f of x dx into a to b g of x dx, but we are putting under square root. We are putting under square root, no, that's why f square g square they wrote. So root of f square g square means what? This side modulus of x. Root of x square is modulus of x. Okay, so this is, I am telling the short trick to remember. Okay, so root of a to b f square dx there. Here both squares square there, so this is always less than or equal to that quantity. Okay, right. I hope that you remember this quantity very well. Dear students, I hope that you enjoyed today's class with some more problems which were useful for your JEE Mains 2023 examinations. I will explain some more problems from almost every topic. So whatever may be the chapters you required, just you put it in the comment box. Definitely I will take up those concepts. Until then, all the best.